Welcome to BTEC Revision. In today's lesson, we're looking at work done. By the end of the lesson, we should be able to calculate the work done by objects. What is work done? Work done, by definition, is energy transfer. For example, let's take a look at energy types. We have light energy, sound energy, thermal, just to name a few. And when sound or light is transferred into thermal energy, then we say work is done. So work done is just energy transfer. Therefore, the units are going to be the same as energy. So the units are joules. Work is usually done when there is a force exerted on an object and it moves a distance in that direction of the force. And we can calculate this through the equation work done equals force times distance. W equals Fd for short. The units for work obviously are joules, as we mentioned. The units for force are newtons, and distance is measured in meters. Let's look at an example. A force of 25 newtons is applied to lift a box vertically through a distance of 2.5 meters. Calculate the work done in joules. So we'll start by drawing a diagram. Here is our box, and we have a force of 25 newtons, and it's being moved a distance of 2.5 meters. And as you can see, the force and the direction of the distance moved are in the same direction. So they're parallel. So we can use this equation. Work done equals force times distance. We can plug in our values. 25 times 2.5, which gives us a value of 62.5 joules. Now pause the video here and attempt this exam question. A force of 20 newtons is applied at an angle of 30 degrees to the horizontal to move a block through a distance of 4 meters. Calculate the work done by the force. As you can see here, the distance that needs to be moved is 4 meters along the horizontal, and the force applied is not along the direction of the distance moved. So what we would need to do is we would need to calculate the component that is parallel and along the same direction the distance is moved. So we would want to calculate this force, the component of F, which is 20. So we would need to use trigonometry. As you can see here, this would be the adjacent because this is the longer side, hypotenuse, and the adjacent is next to the angle, 30 degrees. And therefore, if we remember, that one is cos theta equals adjacent over hypotenuse. Rearranging for adjacent gives us h cos theta. And now we know our values. H is F, which is 20. Cos theta is 30 degrees. So our adjacent, which is our force in the x direction, or the component in the x direction, we can calculate using this equation here. And this gives us a value of 17.32 newtons. So our force in the x direction is 17.32. However, the question is asking for the work done. So we will need to use work done equals force times distance. And we worked out our force, 17.32. Multiply that with the distance of 4. And that gives us a value of 69.28 joules. And that's the end of the lesson. If you would like to boost your grades, Try the quiz questions at btechrevision.com, where there's lots more resources available. See you next lesson.